Hello friends, I'm in the last theory part of this model 3 Vapour Power cycles. I have to explain feed water heater and feed water heaters and reheat Rankine cycle. Right. First of all, in the last video we have seen that is regenerative Rankine cycle, actual regenerating Rankine cycle. What we have done? We have extracted the steam at 2 points. One is at M1 and one more is M2 kg of steam we have extracted, and we have passed them to the feed water heaters, that is high pressure heater and low pressure heaters. There are two types of feed water heaters that we have to study here. One is open feed water heater, another one is closed feed water heater. So open feed water, this is a simple thing. So feed water heater, first we know this one is already we know. So it has a boiler, turbine, condenser. FP1 means feed pump 1 and feed pump 2, and this is feed water heater. We are not, again I am saying here, we are not adding anything to this, only to generate the feed water heater. So here 1 kg of steam is passed, among that y kg is drained or bleeded or taken out from the turbine, and remaining is 1 minus y is going to the condenser. So here turbine work is happening, some part of the white this one is taken and it is in the feed water heater, and here 1 minus y is worked in the turbine, it is coming out and passing to the condenser. In the condenser it is converting into liquid, and this pump 1, that is feed pump 1 will pump this to the feed water heater. Earlier what we were doing, directly pump was supplying to the boiler, but here it is temperature of water is very less, we will increase the temperature of water in the feed water heater. So here how we will increase, we will not burn any fuel, we will take the energy from this Y fuel, that is Y amount of steam from this turbine, and this feed water heater will act as a heat exchanger. This fluid at higher temperature, this fluid which is coming from pump is at lower temperature, heat exchange takes place in between, and the feed water is going into the through this pump will pump the water from this and supply to the boiler. So this is the open feed water heater. So but what is the disadvantage of this is the steam which is coming to feed water and mixing with this pump, but 100% this steam is not converting into the water. So that is the drawback. So that drawback we will overcome in the closed feed water heater. What we'll do? We'll do the second type, that is closed feed water heater. What we'll do? Some amount of steam is remaining here. I'll use one steam trap and I'll supply back to this condenser. Right. So here I will name this as steam trap. So what was happening in the open feed water heater? Directly this liquid was entering and this steam was having a heat exchanging here, and what we assumed was this steam was completely supplying the temperature to that water, and this steam was converting it into water, and that is also supplying that temperature to the water which is coming from the condenser. But the actual case, some amount of part of this Y will remain as it is, so that will trap it and will supply back to the condenser, so that is also condensed and it is in the form of liquid, and this will become one closed circuit like this: steam trap, condenser, fluid pump on, feed water heater, and this will be the circuit, and as and when it is converted into liquid, that is also going to the pump and it is converting into steam, and this will regenerate. So this is closed feed water, and these are simple short note they will be asking in the exam. Explain closed feed water heater or open feed water for a small 5 to 6 marks. So you should study this. Next, one more important in this chapter is reheat Rankine cycle. So reheat Rankine cycle, what we'll do? We have two turbines. We'll keep two turbines. and whatever output of this high pressure turbine will be reheated. So what is the word here? Reheated. So where reheating will be done, I will just explain now. So this is the boiler, this is a turbine, this is one more low pressure turbine, this is condenser, pump. So as good as a normal Rankine cycle, but only thing is I have added one more turbine here, right? So if I have only one turbine, what is the problem is the output of the steam still it has some power, so we are not utilizing that power. So what I will do is, first from the boiler steam is collected and it is supplied to the high pressure boiler. Here it is expanded and output is not sent to the condenser. Output is sent back to the boiler for reheating. So this is what reheater is. So here output is sent to the reheater, then that is taken to the input for low pressure turbine, then there it is expanded, then it is passed to the condenser and it is come back to the through pump, it is again taken back to the boiler. So once here there are two heat supplies are happening, one is at the boiler, another one is at reheater, right? So here we can expect more work output, W net is more as compared to others, right? So only one thing is extra is this circuit we are having 2 and 3. So now this is what is the TS diagram and HS diagram. Just this one. So this is increase in work due to this whatever dotted has written here. It is increase in work due to reheating, right? So this is also in HS diagram I have shown 2 3 4 4 dash 2 3 4 4 dash is the increase, 2 3 4 4 dash is will get through the graphs. So now I need to derive the efficiency for reheat Rankine cycle. So reheat Rankine cycle as good as W net divided by HS, WT that is turbine work minus pump work divided by heat supply. But turbine work, it is very important, don't take only one turbine work here because two turbines are there, work done by the high pressure turbine, work done by the low pressure turbine. So work done by the high pressure turbine in terms of enthalpy, this is the difference between H1 minus H2. This is the H2, here 2, I have mentioned 2, it is 1. H1 minus H2 is high pressure turbine. Low pressure turbine, H3 minus H4, H3 minus H4. See you should always see the inlet, outlet. If it is turbine, inlet is having high energy, outlet is having low energy. If it is condenser, inlet is high energy, outlet is low energy. So this is how we have to see. Next is pump. So pump H6 minus H5. Output is having higher energy, input is having lower energy. So H6 minus H5 is pump work. This is WP. So HS I said it is happening 2 times. So H1 minus H6. For the whole boiler it is H1 minus H6 plus H3 minus H2. Here also it is coming and it is going out reheating. So this is what is efficiency of the reheat cycle. If I neglect the pump work, because pump work will be very small, so if I neglect, so just remove this term and keep as it is, this will become the efficiency of reheat cycle. So friends, advantages and disadvantages I have listed here, please read them, and some of the theory part, almost all theory part I have covered in this chapter. So one more thing is characteristics of ideal working fluid. What is the characteristics? Fluid should be very high critical temperature, it should have, liquid should have low specific heat, freezing point should be low, fluid should be chemically stable, it should not be corrosive, it should not be toxic, it should not be excessively viscous, and it should be available in low cost. So these are the some characteristics which may ask for 2 marks or 3 marks. So this completes theory part of this module 3. So just I will take the syllabus copy of our syllabus copy. So what is the syllabus copy given? Carnot Vapour Power cycle explained, drawbacks also completed in video 1, simple Rankine cycle, description, TS diagram analysis, comparison of Carnot and Rankine cycle, it is also covered in video 1. Effects of pressure and temperature on Rankine cycle and actual Vapour Power cycle is also covered in video 2. Ideal practical regenerative Rankine cycle, and open and closed heaters. Now I am completing reheat Rankine cycle, characteristics of ideal fluid in the Vapour Power cycle. Almost all the theory part I have covered in 4 videos. 4 to already uploaded 3 videos. This is 5th video. 4th one I will upload and 5th one I will also upload today. So this will complete theory part of the module 3. Please watch the videos to be updated with the syllabus. Tomorrow onwards I will start the numericals. Thank you very much for watching the video.